All right. Hello, everybody. What's up? All right. So I got a new maglev for the pulse motor. It's just two big toroid magnets set to oppose each other. It's really neat. Really smooth. Takes away a lot of the noise. We're going to check out our propagator and how to hook that up. I'm not sure how to hook it up. That's why we need to look at it. I can get one segment to work pretty well, but then we'll look at it. So it was really tricky to get that donut on the bottom of this disc. I had to turn the magnets around so they're all facing south now, south out. So this one and this one are hooked up separately to the SSG. And then these two are hooked in series to the SSG. So there's three hookups to the SSG coil output. We're going to go 3 volts in, 3.05. We're going to see how fast we can get it to go on 3.05 volts, which would be approximately, once it gets going, about 0.6 of a watt. Sometimes it's less, but sometimes it's more, so it averages out to be about 0.6. Now we got a nice air gap, so the copper isn't going to affect the rotor as much. And it's a strong magnetic field. It has a good reach. 16 gauge wire. Pretty awesome. It's going to be, I don't even know how fast it'll get going, but that thing will start to shake before I have to stop it. And it's going to shake simply because it's now more elevated on the pole. On the shaft, it's more up towards the top of the shaft than it was before. But maybe I can change that. It'd take a lot of work, but it's like strapped in on both sides of this thing, and it's really solid in there. So in order to make it a little bit longer, I'd have to undo all that and then do it up again. Maybe I will. Okay, 3.05 volts, and now we're leveling off at like 270, let's call it, milliamps, which would be about 0.6, maybe a little bit over 0.6 of a watt. All right, let's see which way we're going. 9, 7. All right, we're at 800 now. It's got a long acceleration phase due to the air gap that I've given it. But this coil I have up close because it's the only one with a trigger in it. I was like, I wonder how I'm going to do all the triggers. And then I'm like, well, I really only need one because of where I'm connecting the coils to. And there's a 4-magnet rotor, and it's 90 degrees, and it's 90 degrees for the coils as well. So it just kind of worked out that way. And we're coming up on 1100 RPMs. Yep, 1102. You can hear it starting to like knock around, and it's pretty centered like that. Those two magnets are like right on top of one another. It's just because of how high it is on the shaft. Alright, so we creeped up to like 0.9 occasionally of a watt, but we haven't reached a whole watt yet. We're almost at 1200 here. That's amazing. So, Mr. Lanius, I got it. I got it that time, man. I nailed it. So we're working with less than a watt, and we're coming out with, looks like 1180. It's going to be close to our max. Well, no, 1182. I don't know if we're going to make it to 1200 with the way it's spread at 3 volts. But maybe. No. It's playing with me now. It's like going down. But if I move them all in right now, we can get up there. No, actually, that's not right. I moved them out so we could get up there. Let me move this one back a little bit. There it goes. 12. Coming up on 1250. Oh yeah. Wow. Back that one out after you start it up. Woo! 1300. Oh, come on. Yeah, 1300. I think this is incredibly fast for 0.6 or let's say 0.9. $13.50. That's awesome. Then we got this right here. This is a mag, basically. Motionless electric generator. But it's going to be a propagator. Or that's what we're going to try and make out of it. So let me turn this one on. I don't know if you can see the light. It's down here. Alright, so the light's on. $61.5 off of the Well, they're sharing a core, but the core is not in the middle. The middle of the bottom coil is a lot bigger than the core. Okay, so the core is just kind of in the middle. There's a lot of air there. It's in the middle of the generator part of it though. For sure, it's right there. We're gonna get 1400, and I'm gonna shut it down so I can focus on this over here. It's a lot of cool noise that goes along with this one. You can kind of hear it humming, maybe. And you get that sweet vibration because there's a core in there. You don't get, you get it, but it's a very less, there's less acoustics to it when you don't have a core. And you got your light to show that the whole section is working. Um, so I'm using the trifilar coil, amp funnel coil. It's a 18 gauge, 20 gauge, and 32 gauge. I'm using the 18 gauge as the drive. I'm using the 20 gauge to light the light, and I'm using the 32 gauge to hook to this 32 gauge, and that's to see if the transformer part of the whole thing there is going to be like have more amps to it because of the coil that's in the trifilar. I noticed that when you hook that particular part up to any other coil system, the oscilloscope gets all excited, you know, it gets all like, what do you call it? I don't know how to explain it. Excited is how I would explain it. So like having that excitedness go through this whole thing, basically just connect the 32 in the bottom coil to the top coil in series and then run it. And we're getting like 61 volts off of the EMF field, pretty much. I mean, I don't know exactly how they're not connected in the trifilar, they're just really close. So in my book, it's okay for those two to be connected, just as long as you're not connected to the drive in any way physically. I think that you can demonstrate what's supposed to happen. And really what's supposed to happen is you connect this coil either into the next drive coil or back into this coil so you can make the one segment of propagator. And it works up to the, I would say, the capacity of the coil. See, once you reach how much at a certain input, and every input it'll change. So I mean, you got to just know that's the thing. That if you turn it up, it's going to go up. All right. Well, yeah. I don't, because normally I don't connect the two. Like it's just either a single wire or bifilar, and they're both being used. So normally I don't connect anything to this except the next load. So it's contactless. So when I lift this up, I can take it all the way up. And all it's going to be connected to is the next load. Do it all contactless. It's not, but you see now it's a little different because it's tethered to this coil. but I'm thinking that the output is going to be that it's that much more impressive. And if we're going to propagate, why not have extra energy instead of not enough? All right. You hear that? So the frequency of this coil is not very high. For 65 volts at 6.9 volts in, we're at 369, and I believe that is the signature note right there. What I mean is, if I go to the next voltage, either up or down in frequency, it's going to go down on the multimeter. So cool, man. That's awesome. And that hum is like so cool. See, let's take the core out. You can still hear it, but there's no resonance. This thing will vibrate. I can already feel it. Wow. And it's not even, there's a lot of air there. It's chilling in the center. The hole is way bigger than the core. And it has just a profound effect. It's rich. The sound is rich. And we are getting about 30 more volts than if we didn't have it in there. The the core is another thing that is connecting the two coils. I mean, not physically, but yeah, physically. I mean, it's inside the field. Um, but like the bottom coil is only being affecting it had in contact with the core by the field. The top one, it's a little bit closer. It's all the copper. It is vibrating very nicely. So we're supposed to take that 65 volts and shove it into the next drive coil. Somehow, some way. I don't know. This part I've struggled with. I've done it a lot of different ways. I've done it with each section having its own transistor. But now we're using the PWM, and it works very well to do what the signal generator does, or what I use the signal generator for. So it's very good. It basically, it's a timer, and basically it pulses the energy through to the coil and back at a given rate of speed. Like, it's an on-off system, given rate of speed per on, and how long between each on, how long it will be on for, the duty cycle and all that stuff. That's all on here. It's really simple though. There's only 6 buttons. All right. Let's turn this on. 3.5. I'm gonna have to push it in a little bit like I, here we go. 26 gauge trigger, 16 gauge drive all the way around. And that trigger is nice. And I got the trigger wrapped back in to the drive of this coil. So when it's off and it's a straight series circuit, like it's not a parallel connection. It'll use the trigger coil as, and these are things that will only work as long as it's spinning. Okay, so it has to be spinning in order for them to work. I know I just said that vice versa, but it's like, yeah, these are not meant for any other type of use, really. And all it is to see if you can get it to spin longer than it would without the mechanism there. If the answer is no, and most of the time it's no, the more you add, the slower everything gets. That's usually how it ends up. And I say usually because there are some exceptions. I think we're about to see one of those exceptions. Like if all of the extra drive coils happen to be the same gauge, that helps out a lot. So they're all 16 all the way around. How you configure those coils also helps. But having just one coil and it going really fast, you'll see that that's very unstable. So you gotta have to use the force, use the forces that be to balance or help balance your rotor. Especially at the higher speeds, you gotta have, something pushing on all sides of it. I mean, I do. With the weight of the rotor and the quarter-inch shaft and how high it is on the shaft. I mean, just like right now, all this stuff can be, switched. But like right now, yeah, it's, I don't know how fast we can get it going without the interference of the copper. Let me back this out now. We got it going because now it's going. Coming up on 1,000. Huh. Maybe it's too far out now. This one is gotta be kind of more in the game than the other three. Now, pushing it in that close, let's see what we got. Yeah, 1015. 1059. Wow. $1,100. And that I believe will keep continuously increasing in speed for a while. But like I said, once it gets going really fast, well, we'll see what happens. I'll try and get that reading if I decide to shut it down, like before I shut it down. 1200. Point 0.9. Now we're at 0.9. So the amps went up a little bit. $1,300. See, nice and smooth. It's a lot less noise than it was before because of the maglev. We're not just resting on a bearing now and being sucked into it by a magnet. We're actually kind of levitating. We're probably as close to center as we're ever going to get with the two toroids. I mean, it literally looks like it's one. If you just go down like this, the line looks like it's just one toroid. It's freaking smooth. But, you know, that's just from where I'm looking. $1,400. Yeah, man, this is great. 0.9 of a watt. Still under a watt. We can call it a watt though. 1 watt. Should probably turn it up a little bit if I want to call it 1 watt though. 1,400. And what do we got? 20? It's 19 right now. 1420. That is going so smooth. Let me just check this. Oh wow. Some vibration in the shaft, but you can it's like it's not that much. But it's increasing, I would imagine. Alright, we're kind of capped at like 1425. I would think, the way it's going up. Anything beyond that is not smart and needs to be left out. What I mean by that is a smart goal. Like it's time oriented, measurable, you know, it's smart. So like right now, the trigger coil for the main drive coil is giving all of its inductive energy to the drive coil because I have it hooked up to do so. I don't know if it's helping, but it's not hurting. That's for sure. I bet you if I turn that around, I just turn the dial around, it would act as a brake. Should I try that? Should I see if I can't make it stop by doing that? I know you can do it with a capacitor, but can you do it with a diode? I wonder. it doesn't seem like it, but we'll see. We'll give it some time, a little bit of time. See, let's see what's happening now that I flip that around. We're taking the energy. No, we wouldn't do that. We would hook it to itself. That's what we would do. But we're not going to mess with it to that extent. We're going to flip this back around because it's backwards right now. All right, now we're taking the energy from the end of the trigger coil and shoving it into the beginning as if it was power to the drive coil. And that's how it's hooked up. It's really simple, doesn't hurt it at all. Don't know if it helps. All I know is that as long as there's electricity being generated, it will continue to spin, and vice versa. As long as it's spinning, it will continue to generate electricity. And those two things, I believe, is what everybody's on about, you know, that you can't really upset that balance when it's dealing with itself. And you got to understand, you change the circumstances, you got to change the equation. You have to change the variables to, be inside the weightless area and everything. I mean, yeah, it's all proportionate in my mind. It's like, yeah, if you take away gravity here, you got to apply that to the whole freaking thing, not just where you think you're taking it away from. And you do that, you might like think twice before doing it. And like I said, like on a global scale, like if it happens on a global scale, you really need to like be aware, in like giant people. And there's a few sites out there that I've seen with like just wow. And yeah, I guess there's some sort of correlation between the gravity disparities and these people. And I don't believe that's too far-fetched of an idea. I think yeah, it's what I'm trying to say is that, maybe I feel like you can't just, do one half of it without the other half being affected. And it's not even necessarily a half, just one facet of, changing gravity here will make something happen over here, whether you want it to or not, kind of thing. And that's the law that I can't shake, in a nutshell. And I could go read a physics book. I think I have a pretty good grasp of what can happen and what can't. I mean, I know there's laws, but it's all jarble in my mind. I'm not saying it's jarble. I'm saying it's jarble in my mind. I can't really talk about it, but like when I'm building stuff, it's there. And let me say, for example, this toroidal over here, the measurement for the outer rim here is very, very precise to within the outer edge of it being a 1/16 of an inch all the way around inside the pole so that I could put bearings. What's up, Mike? What's up? All right. Yeah, this toroidal over here. I was having so much trouble with my printer, and then it finally decided to start working, so I moved forward with this. And it used to have a huge friction problem, and now it's just a little friction problem because the wheel is not smooth. It's got 64 edges, and you can tell in this setup, but that might be enough coastability for it to counter rotate. It's very still sticky though, but if it was flat, it would work very, very well. Boom. And then the rotor doesn't shake nearly as much as it used to. And it's a very powerful magnet in there. So what I'm going to do is I'm going to, let me get a notebook. What I'm going to do no, I thought there was going to be one. There's a package of them in there, but I don't need a Sharpie. I need a pen. Maybe a pen Sharpie. Ah, here's a pen. All right, so the toroidal is 2.5 inches wide. So I was thinking that the former for the coil should be like that, and would go on the inside. So maybe even with 2 holes in it, 1/2 inch thick, and then we take a small chunk of iron and we put them in those holes. Okay, and they're going to be make them 18, or we want to make them 20. Can either do 18 or 20 gauge, and I'm debating how many I'm actually going to have in there and how I'm going to set them up, and whether or not, like I have enough battery containers for 9 volts to put, each coil, if I have 6, has their own battery. So the former is going to be a square or a rectangle that's going to go, all right, here's the toroidal, the inside of it, and I have notches on the inside going across like this at 120 degrees. So at 120, we put one of these coils in right here, like so. Well, that's more of a square, but I mean, you get what I'm saying, like, move it right in there, Get the holes. All right, yeah. So it'll be like that, and this will be iron infused PLA. This will be it will all have iron in it, at least some content. And the reason that I chose the rectangle shape was because the magnet in the middle is a rectangle. Now, I want to align the coils on the toroidal on the inside in a triangle. So that's why I'm thinking maybe elongating the former a little bit so that it's more area covered. Be more like even maybe a serpentine coil, depending on what I use it for, you know? But this one's going to be a kind of rotator, so it's got to be able to trigger. I don't know if a serpentine coil is going to trigger. I know it generates really good. And then if I like chose to hook up a 12-volt DC motor to this bad boy and hook it up with you know, the serpentine coils, that would be sick. That'd be, and that'd be three phase. That'd be sick three phase. I'm gonna make a three phase one right now because it's a bi magnet in the middle. There's only two sides, north and south. So it's technically one north and one south. I don't know, you know, come to think of it, I think it's got to be a pulse motor that's going to make this work because I don't even think a reed switch will do it at this point with the magnet being the way it is. But I know that like a pulse motor with the trigger will do not both, but it'll do one, and then it'll do it again before, you know, it'll go all the way around, is what I'm saying. But to know for sure, for me, I gotta build it because that's a really good question. It's a really good. All right. And all this stuff. There's a lot of stuff that you know people like Mike does, and other people. They Peter Hall effect, and they're all telling me how this stuff works, and now it's like I'm only now starting to glimpse what you were talking about, you know, a year ago. And hey, man, I can't, I don't have anything else to say about it other than, yeah, I probably need to stop smoking. Because, I mean, now that I see it and like how to get BEMF off of a coil, like you guys were telling me how to do that, and I just didn't get it. It was always the other way. It's always a serious connection because I didn't understand how to do a parallel connection until literally like 6 weeks ago. And then once I learned about that, all the voltage went down, but all the power went up. So like I could do more with it, but it wasn't, the numbers weren't as immaculate as they were before, but there was more power. I could do more with it. That's right. Thanks, man. Yep, yep. Okay, here we go. The Meg. I guess that's what they're calling it. You hear that resonance, man? That is beautiful sound. 61 volts being generated from this coil on top. 7 volts in. 1.4 amps being drawn. I don't know how many amps are being generated, but I do know that that sounds awesome. Here, it's 369 frequency, 369 hertz at 50% duty cycle. 66.5 volts. Oh, 65, 66.4. All right. What I think, what is like intriguing to me. Here, let me lift that up. Let me take this away. See how big that hole is? Yeah, and then all right. Yeah, I haven't heard from Double O in a long time, man. Hope he's all right. He was working on a coil apparatus the last time I seen him. Or heard from him. All right. So it's not 10 to 1, but it's pretty close. Pretty close. I don't know like what I'd have to do to increase that. I don't think adding more 32 gauge wire would help. So like I'm generating 65 or 66. And I'm putting 7 in. That's just a little bit less than 10 to 1. So all these 4 coils are timed to the same trigger. And I can do that because they're aligned at 90 degrees. So that's cool. I got the holes up there so that the magnets kind of pass through the center of the coil. Yeah, I decided to put and to get the maglev on there to begin with was a challenge. But once it was on there, it was okay. Let me show you the new disc that I have. It's an old disc, but this right here will line up your toroidal directly with the 1/4 inch shaft. And it's really, really good to have these as close to center as possible. I swear, like these are lined up what I would consider to be very, very well. Very well. I admit when it gets going like 2000, 2100, it starts to shake. But I think it's because it's too high on the shaft. That's what I think. I've been saying that, and I really do think that. was a little bit lower and had the same, you know, floaty effect, man, that would be great. And I can't put another magnet on top. That isn't going to happen. Because the magnets are not, they're just chilling in there and it's not going to happen. I mean, maybe. Now that I think about it, it could very well possibly happen, especially with this new, or this disc that'll center it very well. But literally, I think best case scenario, I get it on there and all the magnets fly up. What's going to happen? That's best case scenario. Worst case scenario, somebody gets like a broken finger, not paying attention. And maybe not a broken finger, but at least a nice pinch. But I think literally if they just came together on your finger, it would probably break it. But I don't know. I don't know. Some like, I know it probably wouldn't break my finger, but it would pinch like hell. Because it would keep on trying to come together and it would actually start to pinch. Because it wouldn't stay like on the finger or the bone, it would just start pinching you. And then it would come together and it would hurt like hell. That's more likely what would happen with these cubes. Now these big magnets over here in the toroidal, like I have two of them. Now those things, like, that's 600 pounds lift coming at you from both sides, man. Because when I had the coils like really close to the rotor, only got like 850 RPMs. Got to back it out a little bit so there's not so much of that. I guess it's what it's called, I don't even know, but permeability, like that ability to like grasp and pull along with it the copper, which is going to in turn act as a brake. And the weird thing about it is it acts as a brake even though the motor's on. It's not weird, but I mean, like, I moved the coils out a little bit and it's going 1500 instead of 850. So I don't know. The distance between two magnets and the degrees of separation are different based on the diameter of the rotor. So I'm always thinking about that. I'm always thinking about like how, and it was a total guess, but whew. Glad I had my TV going today. Glad I had my TV going today. I've never seen that one coming. Alright, let me check the clock. That might be actually a good place. Let me just check the time. We got about a half hour. I do. Alright, enough horsing around. Turn it up a little bit. Like 5.5. $1,600. $1,750. $1,800. There it goes. I'm gonna let it go though for a second. Wow. $1,900. Well, I know it's all jammed in there and everything, but my experience has taught me that that really doesn't matter. It really doesn't. I mean, just it's crazy stuff that can happen. Anyway, I think that's awesome. It is a little bit, like I said, higher on the shaft. It may be even maybe a little bit more unstable, but it's a lot quieter. In my opinion, it's a lot smoother. But there is a stability issue from it being that much higher up. Once it gets going, yeah, I mean, and it's not even the magnet on the bottom, and that's what everybody's going to jump on first, but that's not that. And for once, it's like awesome, man. That thing is fit perfectly. But I say it goes a little bit farther with all these coils on than it did with just the one, because it does help the stability to have, in this case, all the coils having an electric field on all sides. It helps a lot. There, another thing I learned from Mike. that you can balance the rotor in many ways, including by adding coils. Sometimes that's all you need is to have force coming from the other side. All right. So I'll break it down one more time. Got your 26 gauge trigger, got your 16 gauge drive. You have this drive coil hooked parallel to the SSG. So it's this coil, and these two coils are in series, but also hooked to the SSG. So it's all timed by this trigger. They're all going to fire when this trigger hits. And since they're all equally aligned with the magnets, so when it hits, it's going to hit for all the coils, which is, awesome. I noticed there's a great, even when I'm messing with my 9 magnet rotor at 180 degrees, there's a great power increase when 2 magnets are hit at the same time than one after the other. So much more, what, I don't even know, torque? What are we going to call it? So much more power when they hit at the same time than when they don't. Because it's like the 0-1 pulse motor, I don't know, man. I see like when you're in human resources and you have 3 people working a job, it's 2 hours long. You have to mark down 6 hours in your logbook, but really only 2 hours went by. You get it's like man hours. Parallel is like man hours. Because even though there were 6 hours that were transpired altogether, only 2 hours went by. And I guess it all came into play with business, and man hours. Exactly. Because, like, how are you going to get paid? You get paid by the hour, and it's a man hour. Because you got 2 people working a job, you got to pay out twice as much. But only 2 hours went by. Kind of like how I see parallel and series connections. I know that's a weird analogy, but it is. It's how I see it. So I tried running this with the 16 gauge coil and it ended up having like 4 amps by 5 volts. And I was like, nah, nah, we're going to hold off on that. We don't need to be doing that right now. But like this one, we're at 5.5 and 1 amp, and that's 18 gauge. That light is getting nice and bright. 7 volts. Oh wow, that is getting loud. So cool. All right, I'm gonna try starting it at 9. So now we got our output. I don't know if you can see it. Now the SSG is high enough to give out the output. Since it's just a bifilar coil now, there's no extra wire. Yeah, I don't know, man. We could get almost up to 3,000 with it the other way. So I don't know. I might take that off. But it is a lot quieter. That's kind of why I did it. Thank you all. Really appreciate it. It's so it's so smooth though. I mean, maybe not the entire ride, but oh, it's just like so centered. I've never done one that good. It's gonna suck to have to take it off. Unless I can get that magnet on top, and then it'll have a little bit more weight. But I swear it's not gonna end well. I keep thinking about it though, but I think I'm gonna leave that one alone. $20. We're just going through this thing. And that's a lot for me, man. 20 watts is a lot. I blow transistors on far less than that. I get irritated with stuff that likes to blow up. I don't mean that literally. I just mean cease to function. That's what I mean. So yeah, I'm gonna make those former coils, those formers for the coils for this ring over here. And then I'm gonna figure out like how I'm gonna do it, because this is perfect, likely lined up to do a commutator that will make it go. I have a pulley system here that I can use. I'm gonna use what I have though. I'm not trying to buy anything, so you know, if there's gonna be a gearbox, it's actually gonna be a pulley system. It's not gonna be a gearbox. And let me show you what I got. This is what I have. Okay, this is one of them for a 1/4 inch shaft. And then I got a belt, you know, belts that go with it. And then it's got its hook up to its counterpart. But I see any of that stuff going on, and you're gonna have to, I don't know. I don't know, really, honestly. And I don't know if this is gonna work exactly the way I want it to. I know that the rotor will end up spinning, but the stator, maybe not, because it's not flat. It's bumpy. But I can get it to spin. It's just, it needs a lot to make it keep going. But the rotor's good. Can hook up anything to this little shaft right here and spin the rotor any way I want, basically. We're going to try and do it with coils and a trigger, electromagnetism. That's how we're going to try and move this thing. Now, I mean, that sounds really exotic, though, having a gearbox on here that would twist the whole thing as it gets twisted. You know, that would be sweet. And then you could even get the outside to spin faster than the inside. And it's like, that would be awesome. Maybe we could work it in. But I'm just trying to make a pulse motor right now. Hey, Tiggs. Meow. But first thing I did with that toroidal was put this tape around it, and this was a 1/16 of an inch, so it went all the way around and it compensated the hole that was there. But then I'm like, it's not spinning very well. These tubes don't spin very well. I mean, they spin great, but they don't have any spinability, right? So it's not like there's any drag, but they don't spin. But then I'm like, what about bearings? 1/16 of an inch bearings. And voila, man, it works, and it's got more coast than it did before I used them. Way more. It doesn't have much, but I mean, if it has any kick, it's a start. See, this is how I did this. It started off as a thought, like how would I get the toroid to spin? Like, how could that happen? With what you have in your house, where you don't have to buy a crap ton of stuff to make it happen, or even any stuff. You don't have to go salvaging in the garbage or anything like that. You just use what you have that you've already spent money on. and see what you can do. That's my circumstance. I'm not talking about anybody else. So this it ended up coming together like this. I got all different kinds of pieces. I started off with a 4-inch ring, and maybe I threw it all out. Trying to pick up around here. Well, anyway, it started off a lot smaller than this, and then I'm like, the magnets gonna be way too strong for any of that stuff to really function. So we backed it out a little bit. And then I struggled with getting the exact size for the ring to fit in the pipes. Of course, you know, I measured it, but it's really, see, it's a hollow tube that's a 1/4 inch. So if you put the hole for the tube in the center of it, you got to factor that in. You got to do those adjustments. And then if you're going to have a bearing or any kind of thing in between, you got to make that adjustment. See, it's literally just resting in here. And I just wish it was flat. That's all I got to say. Tape won't work. This tape works. The rubber tape works really well because it adds a surface. You know, like duct tape won't work. I've already had 2 layers of duct tape on there, and it doesn't change the bumpiness. You got to make it tight, so it defeats the purpose of the tape to begin with if it doesn't smooth out the surface. So I'm left with that dilemma, because now it fits perfectly and it's bumpy. So that's where we are now. If I want to leave it like this, then we can move forward, but I think that we want to smooth that out somehow. I just don't know how to do it without making a total freaking mess of everything. Really neat though. Oh, there is maybe if we got you know, instead of using these tubes, we used something else that was a little bit more sturdy. Like these poles, instead of the aluminum tubes, but these poles, even though they're straighter and tougher, have a very high iron content. So you get them in close to that magnet, and no. So they gotta be poles, but they gotta not be these poles. But once I get the formers and the coils all put in here, there's going to be a triangle or a triangular shape on the inside of the toroidal. We're going to go square, circle, triangle, square. Just is. Don't know if there's any true significance to that, but if it works, it's going to look awesome. But you know, every time I try a new coil shape, I try to keep my expectations high, but I don't know. Sometimes I give myself some slack, you know, sometimes. So this is going to be like totally, in my mind, experimental, although a lot of people have done like JBL 94 coils. I know that pulse motor 3D PPM. 3D PPM, yeah. What was I getting at? Anyway, he has those big rectangular shaped coils. And I think I'm gonna go kind of that style with these. Except they're probably gonna be a little bit more squarish. And they're gonna fit, like, I'm gonna use those notches that I have in here as a guideline. I got notches at 120 degrees, and I'm gonna use that as a guideline to make my triangle. So yeah, it's all good. I might, all this is probably gonna take me forever to do, but that's okay with me. All right. Well, the next one I do, I'll have this meter hooked up to something. And we'll check it out. Let me get that real quick. All right, so here is one of the neodymium magnets that I tried using as a rotor. Now, I was thinking to myself, I'm never going to be able to get this off without a hacksaw, right? Wrong. So you stick it in here and you start screwing this in. This one's a little tighter than the other one. Huh. Because this one's really lopsided, and I was thinking, damn, I'm never going to be able to get it off. So what I did to make it work finally, basically, is I made the hole. The hole here is 10 millimeters, which is nowhere near long enough to keep the shaft stable. So I doubled the length of the hole that the shaft goes in. And now it's a lot more stable. Boom. What's up, Racer? Please like, subscribe, hit the notification bell, and share if you like this content. Heck yeah. So that's a nifty little way to get these really tight magnets out of these really tight spaces. And I guess if you're reclaiming the magnet, you don't need the plastic anymore. Wow, that's really strong. All right. I'm gonna do this real quick, and then I gotta get my my daughter from bus stop. She'll, if I miss this, she'll get home herself. But mm. I don't know how these things just pop into my head. I don't know how it pops into a lot of people's head, how like just to do something and then it works. It's like, wow. Kind of like the opposite of putting a potato in, but the same kind of concept, just reversed. Potato in the light socket to get the broken light bulb out. Voila. So those, just several times I've reclaimed these magnets now, and I never thought I'd be able to get them back. So that's awesome. All right, so I'm gonna go and get my daughter, and I'll be back probably later on tonight. If not, I'll probably post a video or maybe a short. Check those out. All right. Well, thank you very much. Peace out. I'll check you later. Probably really soon, but I'll be back.